Welcome students. Today in this video I am going to start your next chapter, that is chemical kinetics. The word kinetics is related to motion. Here also chemical kinetics means the study of the speed of the reaction. So in chemical kinetics you will study about speed or rate of various chemical reactions, the factor affecting the rate of the reaction and by mechanism by which these reactions takes place. Okay, now the reactions can be either very fast reaction like the ionic reactions, for example reaction between acids and bases, they are very fast, reaction occurs almost instantaneously. Okay, now some reactions are very slow reaction, that is they may take time to complete, for example a day or few days or few months to few years, they come under very slow reaction. Some reactions are neither very fast neither very slow, that is they are taking place at moderate speeds. For example, the hydrolysis of ester, it is a reaction with a moderate speed. Also decomposition of hydrogen peroxide is also a type of moderate reaction with a moderate speed. Now the main category of reactions for the kinetic study, for the interest of study of kinetics, are the reactions which belong to this category, that is the reaction with moderate speed. We will study the reactions with moderate speed in chemical kinetics. Okay, now why some reactions are very fast and some reactions are very slow? One of the obvious reason is that the reactions involve the breaking of bond, okay, and making of bond. Now different type of bond requires different amount of energy for breaking, and different amount of energy are evolved also when different kinds of new bonds are formed. So the rates will be different. The instantaneous nature of these fast reaction may be due to the fact that the ions are already present in the solution, that is there is no need of energy to break the bonds, so they take so the speed of this reaction is very fast. Another reason is the difference in the activation energy of various reaction, which the word activation energy or the concept of the activation energy I will discuss later in this chapter. Okay, let us see what the rate of reaction is. Now the rate of reaction means the speed with which a reaction takes place. Now consider this hypothetical reaction in which R is getting converted to P, that is product. Okay, just as the speed of a vehicle or any object is expressed in terms of distance per unit time, you must have studied in chapter motion in physics that speed is equal to distance upon time. Likewise in chemical kinetics, rate of reaction is expressed as decrease in concentration of reactant upon time interval or increase in the concentration of product upon time interval. Okay, so the decrease in concentration means R2 minus R1 upon T2 minus T1, that can be written as minus delta R by delta T. Similarly, increase in concentration of product means P2 minus P1 upon T2 minus T1, that means delta P by delta T. Now when we are expressing the rate in terms of reactant, we put a negative sign here, and when we are expressing the rate in terms of product, we are putting positive sign here. Okay, now this sign only emphasizes that the negative sign means the concentration of this species is decreasing with time, and positive sign emphasizes that the concentration of this species is increasing with time. Okay, now take an example of decomposition of phosphorus pentachloride into phosphorus trichloride and chlorine gas. If we want to write the rate of this equation, we will write that minus delta concentration of molar concentration of PCl5 upon delta T. This is put minus sign here. And in terms of product, we will write equal to delta P molar concentration of PCl3 upon delta T, which we also will equal to delta molar concentration of chlorine upon delta T. All the rates will be equal. Whether you find rate in terms of this reactant or rate in terms of this product or this product, you will find the same thing. Okay. Now the rate is change in concentration upon time. So the unit will be mole per liter per second, or it is also expressed as mole per liter per minute. If our reactants are in gaseous in nature, then we will express the rate as unit as atmosphere per minute or atmosphere per second. Now the rate of the reaction depends on the molar concentration of reactant and which keep on decreasing with time, and molar concentration of product which keep on increasing with time. So the rate of the reaction does not remain constant throughout the completion of the reaction. That means the expression we are using to write the rate of the reaction represent the average rate. It represents the average rate. In general, average rate will be equal to delta x upon delta t. Now, if we want to find the rate at a particular instant of time, at a particular moment of time, the rate is known as instantaneous rate, and it is represented as R instantaneous is equal to dx by dt, d in place of delta upon dt. Similarly, rate instantaneous is equal to minus dr by dt or equal to plus dp by dt. The only difference is that if we put limit to average rate equation, it becomes instantaneous rate. Therefore, we can write R instantaneous is equal to limit delta R by delta t or delta P by delta t, where delta T tends to 0. Delta T tends to 0 means at that particular instant of time. Okay. Now, how these rates are actually measured? In order to measure the rate of the reaction, the progress of the reaction is followed by studying the concentration of any one of the reactant or product at different intervals of time. Okay. Now, the most common practice is that we withdraw small amounts of the reaction mixture at different intervals of time and immediately cool down to 0 degree centigrade to arrest the reaction. This is called the freezing of the reaction, and then find the concentration of reactant or the product in the reaction mixture. Basically, titration is used to determine the concentration. Okay. Now, if some properties like pressure, volume and optical rotation etc. are changing with time also, then this method is not working. So, it is very important that except concentration, all the factors that affect the rate of the reaction should be kept constant for determining the rate of reaction, whether it is instantaneous or average. The factors should remain constant. Now, the concentration of one of the reactant is studied at different intervals of time. Okay. Now, this concentration which we determine at different intervals of time are plotted as like this: concentration of reactant upon time. Since the concentration of reactant is decreasing with time, we are getting slope like this. Okay. If we want to find the rate of reaction at a particular instant of time, at a particular time t, the concentration is x. Suppose the concentration is X. So the rate will, to find the rate, what we have to do? We will draw a tangent here. We'll draw a tangent here and then extrapolate the tangent and find the slope. Since we are taking the concentration of reactant, the slope will be negative. Okay, this will give the instantaneous rate. To find the average rate, what we have to do? We have to suppose at time t the concentration is x1. At time 2 the concentration is x2. So to find the average rate, we will just take the difference, that is x2 minus x1 upon t2 minus t1. Okay, this will give the average rate of in terms of reactant. We will put negative sign here. Okay, now in terms of product, the concentration of product is plotted against time interval. Okay, in minute. Since the product concentration is rising with time, the slope, the curve of the curve will look like this. Okay. Now to find out average rate, we have to find concentration at T1. At T1 concentration is x1. At T2 concentration is x2. So the average rate will be x2 minus x1 upon T2 minus T1. Again, for instantaneous rate, we have to draw a tangent at a particular time interval. Suppose at time interval t, the concentration is x. At point x, we will draw a tangent and then extend it and find the slope of the curve, slope of the this line, tangent. Okay, this will give the instantaneous rate. Now, when the molar concentration of all the reactants, number of moles of all the reactants expressed in the equation are equal. For example, consider the decomposition of PCl5. Here 1 mole of PCl5 giving 1 mole of PCl3 and 1 mole of Cl2. So the rate, whether it is average or instantaneous, will be written like this, like d PCl5 by dt, d PCl3 by dt, d Cl2 by dt. Okay, all the rates will be equal, but consider this type of reaction, that is the decomposition of dinitrogen pentoxide. It decomposes to NO2 and O2. Here 2 moles of dinitrogen pentoxide is giving 4 moles of NO2 and O2. Clearly from the equation you will see that the rate of appearance of 1 mole of oxygen is half the decomposition of this N2O5. That means rate of decomposition of N2O5 is twice as appearance of oxygen in the reaction. Okay. Similarly, rate of appearance of NO2 is 4 times the rate of appearance of oxygen, which is also twice the rate of disappearance of N2O5. So the rate obtained by this expressions have different values because they are not equal. So what we are doing, we will divide each rate expression by the stoichiometric coefficient. For example, here we are using N2O5. Rate of decrease in the concentration of N2O5 upon dt, here we will put 1 by 2. Similarly, increase in the concentration of NO2 by dt, we will here divide by 1 by 4. And O2, here only 1 mole is represented, so it will written like this only. For any general reaction, small a, b, x, y, it can be written, rate equation can be written as minus change in concentration of reactant A divided by A, change in concentration of B divided by its stoichiometric coefficient B, change in concentration of increase in concentration of product X upon X, and increase in the concentration of Y by dt divided by Y. Okay, so this is the general equation for expressing rate of the equation. Now to sum up, we have studied that the rate of reaction is equal to change in concentration divided by time interval, okay, in which change has taken place. Rate of reaction can be expressed in term of any reactant or product. And third, the concentration of reactant decreases, a negative sign is used to express the rate of reaction, and the product concentration increases, so the positive sign is used to express the rate of reaction. Okay, now to make the different expression equal or equivalent, the rate expressions are divided by the stoichiometric coefficient, and the slope of the concentration versus time graphs gives the rate of equation. Now let us see what are the factors that influence the rate of reaction. First is the nature of reactant. Nature of reactant, different type of reactant having different type of bonds. Easy to break the bond, faster is the reaction. If the bonds are stronger, then more energy is needed, rate of reaction will be slow. Okay, different amount of energies needed and different amount of energies evolved during the reaction will determine the rate of the reaction. Concentration of reactant. Greater is the concentration of reactant, faster is the reaction, and the concentration of reactant decrease. As the concentration decreases of reactant decreases, the rate also decreases. Third is temperature. The rate of reaction increases with temperature, and in most of the cases it becomes nearly double for every 10 degree rise in temperature. Next is catalyst. What catalyst do? It generally increases the rate of reaction without being consumed in the reaction. So catalyst helps to attain equilibrium quickly, thus makes faster. This increases the rate of reaction. Next is the surface area. Surface area, a solid reactant, if taken in bulk, it will take more time, and if in powdered form, the surface area of the reactant increases. So the increasing surface area will increase the rate of reaction. The reaction will speed up if we take reactants in powdered form. Next is the radiation. Radiation always helps to facilitates. It helps to break bonds faster. Okay, it helps in the breaking of bonds of the reactant. So the rate of reaction also increases if radiation is the use. Radiation, the reaction in which the radiations are used are comes into special category known as photochemical reaction. Okay, so that's all for today. Thank you.